Hello, good morning everyone. Today I'm going to propose no interpretation of quantum mechanics. This is the title in the infinite set signal interpretation and general action of choice of quantum mechanics. Quantum system is modeled as infinite box of possibilities of outcomes, measurement, selection from infinity, axiom of choice. We already know what is axiom of choice, or you can Google it. Superposition, infinite potential collapse relation of one state with finite probability. Imagine infinite balls labeled as 1, 2, 3. Let's say there exists a box with infinitely many balls labeled as 1, 2, 3 up to infinity. We take out a ball from the box. It's either even or odd. Hence the probability is 1/2. But inside the box, inside the box probability is 1 because according to set theory, the cardinality of even numbers is equal to cardinality of all natural numbers. This can be interpreted as number of even numbers is equal to number of all natural numbers. So the probability becomes 1 because probability is defined as number of possible favorable outcomes to number of total outcomes. So it is 1. So this can be thought of as superposition inside the box. Inside the box, all outcomes coexist. Total probability is equal to 1. Measurement. Selecting one ball. So if we take out a ball and see it is either even or odd, we are measuring. So this eventually relates to Germano's set theory of action of choice when dealing with quantum mechanics. Because each quantum state can be interpreted as A plus IB or R equal to E power I theta. The polar forms, this is from Hilbert space in which each is represented as a vector from A and I P. This can be reinterpreted as R e power I theta as we already know. It is polar form. Simplifies operations such as multiplication. Psi1 into psi2 is equal to R1 R2 into e power I theta of theta 2. So it is one multiplication. Calculation becomes one multiplication and one addition. If we do a1 a1 plus ib1 into a2 plus ib2 ib1 into a1 a2 plus ib2, the calculus becomes more complicated. It will become 4 multiplications and 2 additions. The bond rule is mod of y square, which is r square. This is similar to signal energy. When you represent signal in r e power I theta, signal energy is r square. Probability density, energy density complex signals. So signal analysis can be used for quantum states such as Fourier transforms, Laplace transforms, and fast Fourier transforms. Schrodinger equation becomes, we know that ITH dou pi by dou t is equal to h phi describes phase evolution in signal in Hilbert space. For a transform connects the position, momentum, and dual basis. We know that when we know this theorem that is delta x into delta v is h bar by 2 a function as modulated complex signal. Collapse is modulus choice of operation of a C of a is subset of S measurements reduces infinite potential to one outcome. As I explained earlier, entropy reduces H before is equal to infinity to H after is equal to zero. Connects Zermelo's choice with physical measurements. So if we measure a probability wave function in quantum mechanics, it is a Zermelo's choice. Simplifies bond rules computation via polar form. Links quantum probability to signal energy. Provides uniform conceptual model for measurements and evolution. Bridges set theory, signal processing, and quantum foundations. Summary. And the title is Infinite Set Signal Interpretation of Zermelo's Action of Choice and Quantum Mechanics. Superposition is infinite potential states. Measurement is set theoretical choice. That is Zermelo's choice. Probability, signal energy measurements, Schrodinger equation, signal evolution law. So this simplifies this encapsulates the collapse of wave function very elegantly. By Occam's razor, this model is more elegant than the existing models. Thank you.